Okay, perfect. We talked about what is InfoViz. I talked about why we need and we use InfoViz. And now the practical question, how to do it. Okay, fine. I understand the definition of information visualization. I totally agree with you that it is very, very important and it's very practical, efficient, and effective. The question is how to do it now, the actual skill. Okay, so the first slide. How do we know the best practice? As I said, the best practice is important. We can have good visualizations, good plots, and we can have bad plots, the plots that are not efficient or effective. How do we know the best practice to visualize one variable? We start with one variable, the simplest case. So when you have a data set of a few variables, we visualize first every single variable separately, and then we visualize two variables, and then we might decide to visualize three variables together. So we start with the variables and then the combination of them. What if we want to visualize more than one variable? Well, we talk about it. At a very practical level, we need to follow the best practice table, a table that I'm going to show you for each variable type. So the table, in order to use it, you have to recognize the variable type properly and precisely. There is a body of experiment in science behind such table. It's not just a random table or subjective one. There are many experiments behind this table. So it's boiled down out of those experiments and findings. And what are those experiments? Well, they are based on how we perceive different plots better. And the very seminal paper of this branch of science is Cleveland and McGill, 1984. I suggest you to have a look at this paper. Therefore, you need to recognize the types of variables correctly. So this is the key to do a proper visualization. In a systemic approach, we start by visualization of every single variable, and then every pair of variables, and then every three variables. So as I said, we start by one single variable and then combination of the variables. If the number of variables is high, then we have to choose the pairs that matter to us. So even if you have data sets of 20, 25 variables, it's possible to plot every single variable, 20, 25 plots. But then the combination, 2 out of 25, would be something enormous. So in that case, we need to go for those pairs that matter to us. But let's forget about the pairs and focus on the single variables. So the visualization of every single variable, they are called univariate visualizations, univariate plots. Plots that include only one single variable. The following table helps you to choose the best practice for every variable. The variable type, this is the first thing that we have to check, and then the best practice. So if your variable is numeric or quantitative, then the best practice is either a histogram or a box plot, or both of them can be equally good. It depends on your purpose. If your variable is qualitative or categorical, then a bar plot should be used. So quite simple. You recognize the variable type, then you visualize it based on the best practice. In practice, the situation might be too complicated to be boiled down to a simple 2 by 2 table of recommendations. However, this table covers 90% of the situation. So remember that it is not a panacea, it is not a key to all locks, okay? But 90% of the situations can be resolved and can be tackled quite well using this simple table. Let me clean it a little bit. We don't visualize textual variables, and date time might be visualized as categorical variable. So if you remember, we have textual and we have date time. So date time can be considered as categorical and can be visualized by bar plots. For instance, this is 2019 number of accidents, car accidents in Birmingham, and then 2020, and then 2021. So you can see a bar plot can show it. And textual variables, well, we don't visualize text in the row format. Okay, we normally do something on the text and then we visualize it. But anyway, this is a hint about the two other category variable types that they are not in this table. We use histogram when we want to show the items. We want to show how items are distributed over the values of a variable. So we have a histogram, and we will see a histogram very soon. And histogram is for distribution. So this is a density plot. Histogram is something like this, and it is about showing a distribution. And distribution of what? Distribution of the items over brackets of a continuous variable. What about the box plot? We use the box plot when a few points of such distribution matter. So this is not correct. A few points matter, not all of it. Let's have a look at a histogram. It is exactly the same example that we talked about it earlier. So the price is presented on the x-axis, and we want to know that how diamonds are distributed over the price. So we count the number of diamonds in each bracket, in each price bracket. The first one is, let's say, between 0 to 500. The second bracket is 500 to 1000. And the third bracket is 1000 to 1500. And we count the number of items, the number of diamonds in each bracket. This is a histogram. So in the software, when we recognize that this variable is continuous, we present it using a histogram. Cool? What about the bar plot? Well, when we recognize a variable is categorical, let's say cut, we can visualize it using a bar plot. But there is one step between a bar plot and the original table, and that is this frequency table. So what is this frequency table? Well, first, the software counts the number of occurrences of each value of this categorical variable. In other words, it counts how many items have ideal cut, how many items have premium cut, how many items have good cut, and so on and so forth. And then this variable, this table is converted to a bar plot. However, in practice, we don't see this step. Okay? In practice, we feed this initial original table to the software and we get the bar plot. And we can see that the X is about the categorical variable, all the unique values, and the Y is once again frequency. So in a glance, you can see that the most frequent cut is ideal, and then the second one is premium, the third one is very good, the fourth one is good, and then fair. And you can see that the difference between the frequency of ideal and fair is quite high. Okay, this difference, so let me draw it. This is a very large range. How do I know so? Well, I'm comparing it with a benchmark. The benchmark is if all of them had equal height, it would be somewhere, I guess, let's say here. So equal height or equal frequency. And now the difference, the deviation from this benchmark, the equal frequency is quite high. Okay, so one of the categories are very higher and one is much lower. We have things in between. Okay, generally we say that it is more imbalanced than balanced. So the most balanced case is when all these bars have equal height, right? It's totally balanced. Cool. So we want to describe them. We want to comment on these plots on a histogram. What to talk about when you want to talk about a histogram?